Hello, in this video what I'd like to do is talk about what is a data lakehouse platform. And in order to understand really what is a data lakehouse platform, we need to understand what is a data lakehouse. And to understand that, we need to take a look at what traditional systems, or how traditional systems worked. So traditionally we would use databases and data warehouses, which are great because they abstract away a lot of things that oftentimes we'd rather not think about, like how the data is stored. How do we take chunks of that data and recognize them as individual tables? How do we know what tables exist within our data system? And how do I, one, parse an SQL query, turn that parsed result into a query plan, and then execute that query plan? All this stuff is abstracted away in our traditional database and data warehouse systems. Now, this is all fine and good. The problem is, because they're all abstracted away into these sort of unified software sort of silos, what happens? You end up with data silos, because the problem is you might want to use features of one database or one data warehouse of different platforms, but since each data platform has their own way of storage, their own table format, their own catalog, their own way of doing all of these pieces, you have to constantly move and migrate data between systems, resulting in a lot of complex migration processes, resulting in duplication of data, which increase your costs and increase the time to insight, because it takes time to migrate that data from place to place. Data movement slows data insight. So, and again, bottom line is when we take a look at these systems, databases on the transactional side oftentimes store data in more row-based formats, and data warehouse oftentimes store data in more columnar formats. But again, the data was sort of siloed off into these systems. So one way to make the data accessible to more systems was to sort of separate storage from compute. And one approach of doing that was a data lake, where you just essentially had a storage layer that stored all the data, whether it was a Hadoop cluster or object storage, and then you would use data processing systems like Dremio or AWS Athena to run ad hoc queries on that data, maybe sort of some dashboards, but oftentimes you couldn't really do the full range of transactions you could do in those sort of coupled systems, databases and data warehouses. So you still needed those systems. So how could we make this more like those traditional database and data warehouse systems? Well, we're missing some pieces, aren't we? We're missing, the table format and the catalog. So basically, if we introduce those things and then add the capability to do ACID transactions, to do a lot of the types of workloads that you could do in a data warehouse, you create a data lakehouse. So that means we have the storage layer, okay? We have our compute layer, but now we're going to introduce a table format, something like an Apache Iceberg, that allows us to recognize groups of Parquet files on our data lake as individual tables, and catalogs like Nessie that allow us to recognize and bundle those Apache Iceberg tables so we can bring them to different tools, and those tools can discover our group of Iceberg tables. And then we can still then query those tables with ACID guarantees using tools like Dremio. The only problem is kind of making all of this sort of work together, because now everything is modular. You're not getting, this sort of box that bundles everything together. It's not coupled. So that creates sort of frictions in the sense of, like, one, having to stand and run your own catalog service, okay, having to run your own, let's say, Nessie server. Two, having to manage your Iceberg tables, having to run a compaction and do expiring snapshots and figure out that cadence and figure out what the right way to do it is, and do all these things that you normally wouldn't have to worry about with a traditional data warehouse or database that abstract these things away. So this is where sort of the need for a data lakehouse platform comes in. It allows you to execute that data lakehouse architecture, so that way you can reduce your costs because you're not duplicating data as much. You can decrease your time to insight because you don't have to move the data as much. You can get it to a usable form quicker, so that way you can get insights quicker. You get that flexibility without the extra sort of maintenance and hard work that might come with that when you have a decoupled system. Okay, so essentially a data lakehouse platform is sort of a wrapper around these loosely coupled components, making them feel coupled without necessarily putting you under some sort of lock-in, putting you in some sort of box that eliminates the benefits of that loosely coupled architecture. And so what should a good data lakehouse platform contain? Well, a good data lakehouse platform should be able to connect to your data lake, right? So, and it should be able to connect to your data lake, whatever is your data lake. So it should be able to connect to your object storage, whether that's ADLS, S3, Google Cloud. It should be able to connect to Hadoop clusters and on-prem object storage solutions. And it should be able to read table formats like Apache Iceberg and be able to recognize the tables that are on your data lake so you can work with them. Okay, allowing you the first step in providing unified analytics, being able to bring all your data together sort of into one platform, which also means being able to combine the data you have elsewhere. Because, I like to think of it as like an 80-20 rule. Chances are, if you execute data lakehouse architecture, probably about 80% of your data will be on the data lakehouse, but you're still going to have this sort of long tail of data in other places. You might be using different data marketplaces like AWS and Snowflake. You might have data in some relational databases and some NoSQL databases. So you're going to want a platform that allows you to bring that data in without having to move it. Being able to connect to those sources so you can unify it all in one place and be able to curate that data and organize it in an easy to understand way through a semantic layer, which also allows you to govern that data so you can control how people use it and document that data so people can better understand the data that they see when they look at that semantic layer. So this whole unified analytics story. But also a good data lakehouse platform should have a powerful SQL query engine so that way you can query that data you have unified on this platform, allowing you to federate queries across all these sources, whether they're in the cloud or on-prem, giving you sort of that hybrid lakehouse flair, but also allowing you to have optimal performance because the engine is fast, which is going to lower your costs because faster queries means shorter lived compute, which means lower costs, but also be able to take it to the next level with acceleration for use cases like BI dashboards and things like that, have those types of reflections that you may need for those really, really large data sets. Okay. So that way you can do that federation, do that virtualization at scale. Okay. So a powerful SQL query engine that's going to allow you to save money, get those queries done fast. But remember, there's all that compaction, all those expiration of snapshots, all that kind of work that takes to maintain that 80% of your data that's going to be on the data lakehouse in this type of architecture. So you're going to want robust lakehouse management features. You're going to want a data catalog that's incorporated into the platform, but not locked into the platform. You can still take that data catalog to other tools if you need to, but that catalog should be able to track your lakehouse tables so you can bring them anywhere you want and use it within the platform, but also be able to offer you next-gen data ops features. So that way you can do things like catalog versioning. So that way you can isolate changes to your data on a branch, like you could isolate changes to code on a branch. Being able to create no-copy clone environments, being able to roll back the state of your catalog whenever there's a disaster, being able to do all these sort of quality of life things that sometimes weren't even possible in databases and data warehouses that are sort of new to the world, not only new to the data lake, but new to the data space. But also at the same time, getting rid of having to figure out all the maintenance of your data lakehouse because the platform can auto-optimize your tables, auto-clean up your tables, so that way they just work. So that way you really do have that data warehouse-like feel on the data lake where it just works. You have the feeling of a tightly coupled system, but using loosely coupled components so that you have that flexibility, okay, giving you the best of all worlds. And the platform that really kind of gives you all of this should also allow the end users to be able to connect to that data really easily using the interfaces they already know. Things like ODBC and JDBC, which oftentimes power most connectors to BI tools. Okay, a REST API, so that way you can programmatically automate activity on that platform. Aeroflight, which allows you to even more quickly pull data from Aeroflight compliant servers. Okay, leveraging that open source in-memory standard format of Apache Arrow that allows not only query engines to process queries really fast, but also allows data to transfer quickly between systems through its Aeroflight protocol. So offering you all these ways to move the data so that way you can use it for data science, dashboards, applications. Okay? So that way all your use cases can benefit from your data everywhere. You can take your data from anywhere and deliver it everywhere. And the platform that takes all of this and puts it all together is Dremio, the unified Lakehouse platform for self-service analytics. And the great thing about Dremio is not only does it provide you unified analytics, an SQL query engine, Lakehouse management features, but also it gives you many modes of deployment. You can deploy it in a self-managed way using our Kubernetes Helm chart. Okay, and that Kubernetes Helm chart also has features for sort of auto optimization, so that way you can spin up new nodes as needed, depending on the rules that you set, and be able to scale down, so that way you always have the capacity you need in that self-managed environment. But then we also have an even easier to use Dremio Cloud SaaS version, where you can just easily sign up over there at dremio.com, connect your AWS cloud or your Azure cloud, and you're off to the races, with its own set of auto optimization features that allow you to choose between different engines of different t-shirt sizes, large, extra large, small, extra small, being able to determine how many of those engines can be, or how often can those engines be replicated for concurrency, when do those engines turn off, what queries should be routed to different engines, giving you that flexibility to make sure that you are using your capacity the way you want and only spending on what you need. So Dremio is that data lakehouse platform that puts all of this together for you to really have that data lakehouse, that true data warehouse on the data lake type feel. So the next question becomes, how can I get hands-on? How can I take this to the next level? Well, the answer to that question is, well, scan these QR codes. If you scan the QR code on the left, it'll go walk you through a tutorial where you can spin up Dremio, Minio, and Nessie on your laptop. So you can actually kind of see the feel of the data lakehouse right from your laptop without having to spin up any cloud infrastructure. And the QR code on the right will allow you to will take you to where you can actually start getting started with Dremio into production, whether by using that Kubernetes Helm chart or by using our cloud SaaS software. But with that, I hope you guys all have a great day. And again, Dremio, every year we put together the Subsurface Data Lakehouse Conference with all sorts of really great talks about the data lake. Make sure to sign up over there at dremio.com/subsurface. Have a wonderful day, and I'll see you all later.